Today what we're going to be looking at is we're going to be proving one of the grade 12 theorems. You'll see here it says, given DE is parallel to BC, prove the theorem that states AD over DE is equal to AE over EC. And what this theorem is its proportionality, because we've got AD over there, and this should be DB. AD over DB, that over that, is equal to AE over EC. Okay, so there's three parts to this theorem. The first one is just quickly showing that the triangles are similar. So let's go ahead and do that. Right, now the first thing to note here is that we've got these parallel lines, so that means that ADE is equal to ABC, and these two, in other words, these two angles are equal, right? Angle E is equal to angle C, and obviously angle A is common. Right, so we're going to write that down, and we're going to state that they are similar. We've got, so angle A is common. ADE is equal to ADB. And AED is equal to ABC. ACB. Okay. And the reason for both of these is corresponding angles. And don't forget to mention your parallel lines when you get something like this, one of those basic grade 10 things. So this is because DE is parallel to DC. All right, excellent. So, all right, now that we've proved that they are similar, basically we've got triangle ADE is similar to, and remember the order is important here, it's, well, A, B, C. Okay, triangle ABC. Cool. So you can take a minute to pause there and get that done. I'm going to rub this out and move on onto the second part of the theorem. Have seen so far that these triangles are similar, which is going to be helpful to us. The next thing is for us to prove that they have equal areas. So we are actually going to split this up now. We're going to split this triangle up into two triangles. And we're going to show, using one of our other Euclidean theorems, that the areas are equal. And that's going to be important for the third part of the theorem, because we're going to use the ratio of their areas to get the ratio of the sides. Okay, so let's take a look at the second part here. So we need to, once again, we need to remember these constructions. We are going to construct DC and EB, okay, and that's going to give us something like this, okay. Okay, so if you see there, I've constructed DC and EB, but I've also highlighted the two triangles that makes. It makes triangle DEC and triangle EDB. Okay. So rather than seeing this as two triangles left and right, we are going to see the top half and then these two triangles in the bottom half. Now, let's see what we have here. The area of triangle ADE is equal, obviously, because it's the same in both. So we don't really have to prove anything there. But the area of triangle BDE is equal to the area of triangle DEC. Okay, and we're going to say why now. So forget the little triangles. Okay, the reason why their areas are equal is because they have a common base, DE, and they are between parallel lines. So the fact that they're between parallel lines tells us that they have a common height. Now, if the base is equal in length and the height is equal, then we can say that they have the same height. And the reasons will vary a little bit. Obviously, when you're going through the Euclidean of triangles, we will go through all those reasons, but for now we're just going to use them. The base is DE, and they have this common height because they're between parallel lines. And so we're just going to give our reason here, and we don't really need to break it down for them. We just give our reason as triangles with common base between parallel lines. Okay. Cool. All right, so how does this help us? Well, this is where we get to the third part of the proof. And in this third part of the proof, what we're going to do is we're going to use the ratio of their areas to get the ratio of the sides. So to do that, we want to show that AD over DB is equal to AE over EC. Now you'll notice that these triangles have common vertices. So we can say area of triangle ADE over the area of triangle EDB is equal to the area of ADE over the area of DEC. EDC. Okay, so it's that over that is equal to that over that. The green triangle over the blue triangle equals the green triangle over the red triangle, and that's only because we're using the same triangle on the top. So obviously these two areas are equal. On the bottom, we've already shown that the areas of these two triangles are equal, so this ratio is correct for that reason. Now, going from there, we're going to use that common vertex rule. So ADE and EDB, they have a common vertex of E. We can cross out that E, and we're left with the ratio of their bases. So again, if we have a common vertex and the bases are in line, then the ratio of the area is the same as the ratio of the bases. And so we say area of, well, we can actually leave out the area now, sorry. AD, this tells us AD over DB is equal to, okay, and then over here for these two, the common vertex is D. So that's AE over EC. All right, so now we're nearly at the end. We've actually shown that these are equal, but we mustn't forget our reasons. So the last thing here is this: the reason for this, the theorem that we use here, is common vertex. So I'm going to give both reasons here. Common vertex, for the left-hand side, it's common vertex E. right hand side we have common vertex D. Okay, so once again, if you guys are confused about any of these theorems, I suggest just go through your revision material for the similarity theorems. But that is how this proof works from start to finish. And it's one of the two major Euclidean proofs, one of the two major ways they can ask for grade 12 Euclidean proofs. Okay, obviously you still need to know all the grade 11 ones as well. Thanks very much, guys.